Welcome to Electronic Specify Insights, the podcast for electronics engineers. I'm your host, Paige West. In today's episode, I speak with Chris Williams, Head of European Sales at SolderStar. We speak about how thermal profiling has become increasingly important in modern electronics manufacturing, and take a look at some of the company's latest tools and innovations that help improve overall manufacturing efficiency. I hope you enjoy this episode. Let's get started. I am pleased today to be joined by Chris Williams, who is the Head of European Sales at SolderStar. So thanks very much for joining us, Chris. How are you?
I'm good, thank you very much, and thank you for having me.
You're very welcome. Why don't you give us a brief introduction to yourself and your background to start with?
Obviously, my name's Chris Williams. I'm a Welshman born and bred, although I work for a company based in Manchester. My job is European sales, which is something that I've done since I pretty much started the workplace. I've been in electronics my whole time, working for distribution originally in the UK, and then for working for a couple of the manufacturers before joining SolderStar around 10 years ago. It's getting close to now.
Fantastic. And can you tell us a little bit about SolderStar as well and what it is the company does?
Yeah, SolderStar is a specialist profiling company focused solely on the electronics market. So our basic principles is to create products for the electronics industry to use in their production. And I think the main advantage that we have for that is because we're so focused, it means that when there's a new process created, when something is happening within electronics, we know about it, we hear about it first, and we react. It puts us nicely within electronics because if you imagine the broader market being on any thermal process, so from bread baking through to machine welding and everything else in between that's got to do with temperature testing, whereas we solely focus within electronics.
Fantastic. And following on from that, thermal profiling has become increasingly important in modern electronics manufacturing. So I'm interested to hear how you've seen the demands evolve in recent years, particularly with the rise of miniaturized and more complex components.
Yes, it's a question we get asked a lot. When I originally did my college course, obviously things were very different in the electronics that I was building with a soldering iron through to where we are now. The biggest difference you'll see is in the board density. We talk about miniaturization, and so many of the pads now are underneath the component. They're no longer happily on the side with a 3mm gap where you can solder them by hand. It's all surface mount. It's all very dense, and the complexity of those different components. So if you would think about it, you've got a really, really small component next to a component that's 10, 20 times the size on a board that's super thin that's needed to be kept in the same profile window. It becomes very different, very difficult for the modern engineer.
And in the current climate where there's increasing pressure to improve operational efficiency, how do you see profiling solutions helping manufacturers achieve faster throughput without compromising on quality?
That's, again, quite a good question. It's all about the user interface. So to keep things simple and understanding to electronics engineer, there's only a limited amount of time you want to spend profiling. Profiling in its very nature is not producing. It's checking the product. It's all part of the MPI, and it's downtime of machines and it's downtime of engineers. So what's really important is the tools like we have, like the AutoSeeker, where if you put in your profile limitations, which comes from your solder paste manufacturer, we can quickly automate and find ways of making sure that that goes within the actual windows of the target. So you would put the product through once with the profiler, we would see what it's achieved, and then we would use our advanced software to tell you the settings to change it to actually make it work within that window. So as opposed to profiling for half a day in a day, and in some of these big places, they actually have a profiling engineer who all they do all the time is just profile. It's easy for one person to pick it up, give a rough idea, and for us to prove it. And obviously, we would always recommend checking it a second time, but that's all it takes. It takes profiling from half a day down to 2 runs.
Can you share with us how customer expectations around process control and quality assurance have changed, and how SolderStar has responded to these shifts?
Of course, I think the way of looking at this, it's not so much the manufacturer's opinion that's changed. It's more to do with the end customer. So the OEM user, if we think of automotive, it's the people who are actually placing the orders with the electronic manufacturer who are demanding certain applications, and all of them are demanding certain targets slightly different, whether it's historic, whether it's their own product, or whatever's happening. They're all demanding something a little bit different. And the actual manufacturer themselves somehow have to fit into that process. They have to fit into the fact they need to test the ramp rate specifically for this customer. And then for another customer, they're more concerned about the temperatures and the environmental impact of the nitrogen equipment, things like that. So we have to generally be able to incorporate all those different products now and all those different requests.
And SolderStar is, I mean, you've given us a great introduction already, but, the company is recognized for its innovation in thermal profiling. So I'd like to focus now and ask if you would mind to walk us through the development and capabilities of your latest innovation, which is the Reflow Shuttle O2, and how it sort of differs from traditional profiling tools, and the importance of real-time oxygen monitoring during reflow soldering.
So at SolderStar, we've sort of recognized that the original profiling, which of course we still sell, is very much temperature based. But the oven manufacturers have turned the actual whole process of their oven completely around. It's now a controllable environment where you have things like vacuum installed, you have vacuum ovens, you have a nitrogen coming in that is specifically focused on electronics to stop the oxidization forming on the metal pads. Well, if you can set it, if you can control it, then you need to monitor it. So what we created was a profile shuttle, which is just right next to me now. And we use it for monitoring the entire environment of the electronics furnace. So with that included, we include vibration. We obviously do the temperature check-in. And the idea is it's a simple pass-through device that gives the engineer, the maintenance manager, all control over what they're doing. If they can set it, then we can check it.
And you offer a range of verification tools as well. So Reflow Shuttle, Wave Shuttle, Selective Shuttle, and Vapor Phase Profilers. So what are the key differences in how each tool supports specific soldering processes?
Well, every process is different. And it's part of us understanding those differences. So again, when you're only measuring the temperatures, you're limited to just, as we say, checking the temperatures. But if you think of things like the wave, because of the smart way our SLX logger work, we can actually use different sensors. We're not tied into just using standard thermocouples. The reason why I go around and talk about the thermocouples is it is important, and measuring temperature will always be important. But when you have a big wave machine, it's measuring the contact time. And the contact time on the pins needs to be exact. If you use a thermocouple to measure the wave temperature and think you're measuring the contact time, it's not correct. A thermocouple close to a 260-degree pot of molten metal will always say it's hot. It's not lying. It's hot. If you put your hand there, close 1 millimeter away, your hand will burn. It is hot. However, that's not contact. So we use exact contact sensors measured in hundredths of a second for the exact contact time on that pin, and we use the temperatures to measure the preheat. We only use the temperature sensors purely to measure everything else. And that's just for wave. When we think about selective, it's a moving wave. So our pins have to be moved in different locations so that we can measure the X and Y speed, the flux placement. On a standard wave, the flux is sprayed everywhere. On a selective machine, it's local targeted flux. It's local targeted selective soldering. So we put little flux sensors in the four corners. We put flux between it, And all it does is create a little bridge, and we put a little current through the bridge and we check it's in place. It's simple, very thought through electronics engineers made for electronics engineers.
Brilliant, simple and effective. And I think we're also seeing a trend towards more flexible production lines to cater to the low volume, high mix manufacturing. So how do your profiling systems adapt to this shift and help improve process control in such environments?
So we've moved ourselves towards the oven verification, which is where we spoke earlier. Where we're looking at is in the process time of changeover. Obviously, we've got the advanced software that can get everything in the window quickly, but that's usually new product. In the ideal world, a manufacturer wants to step away from profiling every single time they change the oven, which is where we use the verification tools. What we try and do is you give a base point and we check that base point, and say you check it in the morning and you check it's within 2 degrees and the vibrations within 5 millig and the oxygen levels are down to 500 or whatever the target level is. And what you're doing then is creating that base point and you're checking that base point. Well, later in the day, if you're just changing the oven profile to one that's 5 degrees hotter, it'll still be correct as long as you check it every day. What you can't do is wait for the specialist inline systems that are permanently attacked to respond fast enough. They fail, they waiting for a certain amount of clarity in the system. And so as a default, the alarms are going off regularly, especially on constant changes, and people are ignoring them. Ignoring them is the problem. The alarms are there for a reason, but if people aren't using them, then it's a pointless exercise.
And following on from that, how do thermal profiling technologies help manufacturers stay compliant with things like, evolving regulations and standards for soldering and electronic assembly?
In a general rule, and not focusing on SolidStar products on this one, obviously the temperature's lower. People have always had to achieve targets, limit wastage and all the other things that are attached. But now we have regulations like the ISO 14001, the environmental one, and they're asking for continuous improvement. Well, with our reflow shuttle, we can check the nitrogen usage. No one else is able to put it through and check everything in one go. And it's a simple way of checking, am I using the correct amount? Because if a seal is broken, you're using too much. You're not losing enough. You've got the amount going in too high, and it could be an easy seal fix of £500, 500, 600 euros, and yet you're losing 1,000, 2,000 euros a month of nitrogen. And not only that, the environmental impact of creating that nitrogen, all that can be monitored by our products.
So how can manufacturers use profiling data not just for defect detection, but say as part of a proactive strategy to improve overall manufacturing efficiency?
Again, a really good question. And it comes down to the verification equipment. If we spoke about contact time and how we can monitor it in hundredths of a second, if it starts to deviate by half a second, you have a problem. If it starts to change a little bit, it's on its way to being a fail. It may not have failed yet, but it's on its way to being a fail. The exact same with the vibration. We measure the vibration in milli-G-force. Nowadays, in the bigger factories, people schedule the maintenance. Well, it may not necessarily be needed to do maintenance. If we can actually monitor the whole environment, the vibration, the nitrogen levels, the temperatures, the conveyor speed, the vacuum levels, and all the seals and everything around the oven, then you don't need to do maintenance until you start there going, I need to do maintenance soon. If you've got the data, you know. When you haven't got the data, you're having to check. You're having to do the maintenance anyway. And all we're doing is providing those departments with the data so that they can do their verification, they can check it, and they can decide, do I need to stop this line? Because stopping a line is money. And we can save money by telling people there's no need to. or the exact opposite and telling people there's need to and do it now before you've produced too much and created all the wastage.
So for manufacturers considering investing in profiling systems, what measurable improvements or ROI can they expect from implementing SolderStar solutions?
Understanding and efficiency. I think that they're the two words that I would take from it. The SolderStar method is efficient. Using the verification tools doesn't require an engineer. It requires an operator to do it. They can put it through. Any operator can do it inside the machine. It's not got thermocouple wires attached to everything. It's a simple plug and play palette that we pass through. All the operator has to do is download it. That gives the engineer the ability to understand what's happening in their oven and the efficiency to not have to profile it themselves. If we're not profiling every single product with this tool, all we're doing is checking the status of the oven. And if the engineer is happy, it can carry on. They can set their own limits of where they see it as a problem, because historically, everyone tries to hit certain targets, but it's very different now. If you're building a very, very small mobile phone board and all those little USB keys that are smaller than my thumbnail, to if you're building a tank controller, the types of PCB involved, the difference in the actual materials, the components are vast. So sticking to the traditional rules of having to do maintenance every month, it's not needed. So we can survive with good efficiency and, of course, giving people understanding of what's happening in the environment they're expected to work in.
Brilliant. And finally then, Chris, what do you see as the next big challenge in soldering process control, and how is SolderStar positioning itself to help address it?
So our biggest advantage is speaking to customers. It's always the way that we find out what's happening that's new. We have close links to the manufacturers of the processes, so the selective machines and the actual reflow ovens themselves. And they tend to talk to us about what they're doing next. And the answer is for us to come up with a solution that works. Once something's on the market, it's already too late. And we can help them by proving their technology, by creating something first. And the big advantage to us is the SLX logger itself. It's a very, very powerful logger. Because of the smart link and the way it's processed, it's thought out, knowing that the processes are going to change. We already know from some of our manufacturing friends that they're where they're going next and the requirements it's going to have. So things like soldering robots, if it's settable, it needs to be proven that it's set correct. Those are the things that we'll start to look at next. We'll expand on our verification tools. The reflow shuttle has been a great response for us and a great product in the marketplace. So we'll look to move in some of those features onto different parts of our products, on different parts of our environment and our offering. And I think generally our placement will be to continue the excellence, to continue the electronics focus, and just to stay exactly what we're doing and make sure we stay abreast with what our customers' needs are.
Brilliant. Well, before we wrap up then, Chris, is there anything else that you wanted to add?
No, I'm just happy for the time to come and chat to people. Obviously, if anyone wants to contact us or speak to us about any of the profiling needs or any problems they have, then either go through yourself or through me. We're welcome to have a conversation.
Brilliant. Well, thank you very much for your time, Chris. It's been a pleasure having you on, and thank you also for your insights today.
No problem at all.
Thank you for listening to this latest episode of Electronic Specifier Insights. Don't forget to subscribe to the series to keep up to date with our newest guests, and do share with fellow colleagues, friends and family who may be interested in the latest news from the electronics industry.